It was a Wednesday afternoon before Thanksgiving, and I was finishing a few things up before I was heading out when the team received an email talking about an intermittent problem that was happening with one of our sales applications. A user, when selecting an option in our web application, was receiving an error. Now, not everybody would receive an error when they'd select the option, and as a matter of fact, when this user clicked the option again, they were successful. Now, from the email, it was uncertain when this problem had began and how many sales had been affected. Now, flash forward an hour later, the issue had been escalated. The DevOps team is on a WebEx call with many agitated people. Agitated managers are in our cubicle aisle. They're looking for answers. And it's understandable. It's the day before Thanksgiving. It's a production issue, and it's our sales application. So the team's frantically looking through logs. We're checking deployments that had happened the previous days, any sign for what could happen. Finally, we stumbled upon an email about a configuration change that had happened the previous week. This change was made directly to an application instance, but unfortunately, those instances were not bounced at the time of the change. When a code deploy occurred a few days later, the applications were restarted and the change was applied. Unfortunately, the configuration change was missed on one of the application instances, hence the intermittent issue. Now, of course, this change had been applied in other environments and had been tested, but unfortunately, the person applying this change in production had made a few small mistakes. So we had to transform our configuration management. Now, how do we accomplish this transformation? Well, transformation is really all about continuous improvement. Now, we all envision this glorious end state, right, where all of our application instances are containerized and we have systems that detect and fix errors while we go get more coffee. But the reality is, we're nowhere near that. We never really reach that nirvana where there's no challenges, there's no issues. There's always going to be challenges. The goal is to face better challenges. So when I was 15 years old, I had to walk everywhere. I had to walk to school, I had to walk to work, I had to walk to my friends' houses. And so when I improved my situation and saved up and bought a car, I no longer had to walk anywhere. Now this definitely was, I still had to pay gas, I had to pay for car insurance, and I had to get my oil changed. But these challenges were definitely better than having to walk everywhere. So today I'm going to discuss the steps we use for continuous improvement. I will also dive into the 24-hour fitness case study where we use Console and Vault as an integral part of the solution. And then I'll also go over some of the new, better challenges in our continuous improvement journey. So first, a little bit about me. My name is Jason Yo. I'm a senior DevOps engineer at 24-hour Fitness. Now, 24-hour Fitness is the second largest fitness chain in the world. We won't name the #1 fitness chain. In my previous roles, I worked at Cisco as a cloud engineer and then as a technical architect at AT&T. So I have about 20 years experience in the industry. Now, a little side note, since we don't have a Q&A session at the end of this talk, if you have any questions, you can email me at this address. It'll be up at the end of the presentation as well. And of course, if you see me walking around here at the conference, don't hesitate to come up and ask questions or have a chat. I'm more than happy to talk to you. So let us talk about the steps of our continuous improvement process, okay? So the first step is to identify the challenges. And this step is really about communication, right? For us, we had many sessions with development teams, operation teams, and it's really about gathering all the positives, the negatives, issues, roles, responsibilities, all the processes that currently were in place for configuration and secret control. And as you will see in our case study, we found some common challenges that came from these sessions. The second step is to find the value. Now, this idea is to make the simple changes that provide the greatest benefit. Now, we don't have to solve for everything, right? Because in continuous improvement, we will eventually face those other challenges and we'll overcome them. And it's really about identifying those key changes that bring the most value right now. And also remember that value changes are definitely momentum builders, right? Especially with executive leadership. And they help us along that journey of continuous improvement. So once we find the value challenges, we end up defining the path. And this is really about building the requirements. It's about architecting the solution. It's about defining those processes, those business processes that other teams need to follow. It's really also defining the tasks that need to be executed. This step also includes the research that goes into it, the technology, the processes, and really a key point is to look at the successes that are inside your organization and outside your organization. And the next step is walk the path. Now, this is obviously merely the execution of the tasks. It's implementing the technology, and it's socializing the business processes. So it's making sure everybody in the organization is on the same page, right? That we're all moving in the same direction. And remember, the improvement journey doesn't end with this step. It continues back again. So let us dive into the case study at 24-Hour Fitness. So we held sessions across the organization with development teams and our operations teams. And we wound up with a pretty extensive list, right? There was a lot of issues that people brought up. But we identified 4 challenges that solving would actually provide the most benefit for our company. And so the first challenge was to eliminate configuration sprawl. So in our environment, we had configurations in many different files, in many different directories, and it wasn't consistent across applications, right? Different locations and different applications. We also had different configuration management tools. Some configurations were managed by Chef, some were managed by SVN, some were actually stored locally on the instance and they were managed there. Our second challenge was to eliminate the secret sprawl. Again, we had secrets that were stored in multiple files and multiple locations, and it wasn't consistent across applications. Now, one of the big problems was changing passwords. Again, to stay compliant, we actually have to change our passwords, right? Every so often, particularly our database passwords. And so our database passwords were stored on these local application instances, albeit they were encrypted, right? But this process really was tough at 3 in the morning on a Sunday when an application wouldn't start because a password change had been missed. We also had to define a consistent lifecycle process for both configurations and secrets. So again, in talking to different teams, we had multiple processes for how to create, update, store, delete these configurations and secrets. Now, a lot of it had to do with the fact that each team had multiple tools to manage this, but there's also no clear role definition or responsibility definition for the teams. So once we identified the value challenges, we were able to define the path, right? So we built our requirements, we did our research, we architected a solution with specific tasks to be executed, and I've highlighted some of the high-level directives for the solution. So the first one is to implement a single source for configurations using the console KV store. The next one is to implement a single source for secrets using Vault. And again, what these both sort of resolve is that issue of that configuration sprawl, right? With configurations in multiple files, multiple locations. When somebody needed to find out where configuration was, there was no documentation. And we had to hunt basically through directories to find. So here now we're implementing a single source, right? A single source of truth where we can actually go and make changes and manage these configurations. And to go along with that, all of our applications need to be able to access that single source of truth. So again, if you make a configuration change, all of the instances actually get that change instead of having to go from instance to instance and validate that they've got that change. Another requirement was these applications need to receive runtime configuration changes. In today's world, we want to be a 24-hour shop, right? Our applications always need to be up from our customers, especially at 24-Hour Fitness, right? We have people working out at the gym at 2 in the morning. That's what they do. And so we want our applications available to everybody. And so the idea is if we're making configuration changes, we need these applications to take them hot. We don't have time to restart our applications for that change to take effect. We also need to implement a consistent configuration and secret data structure and naming. So again, different teams had different naming standards for their keys and their values and their configurations. And we also wanted to build, as we'll see a little bit later, a structure of when we talk about a particular value, where is that value found? And that everybody understands and speaks the same language. And to implement all this, we need a console agent running on all our application instances so that they can actually access their data. We also want to secure access to console by implementing ACLs. So again, with the console UI, anybody has access to change, modify, add, delete any kind of keys. And so this creates a problem. We don't have an audit trail. We don't know when it happened. And so the idea is to really lock the UI down and provide another management tool for developers to go ahead and create configurations, delete configurations, add configurations. And applications will actually access their data using a token and policy procedure. The same thing applies. We want to secure access to Vault again. We want to secure down that access to the UI. We don't want everybody to come in and add secrets. We want a single admin team to be able to manage that. And then applications are going to use tokens and policies to access their data. One of the key ones here, again, being a 24-hour shop, right? We need our applications up all the time, is to always have a functional path between our application instances and the console and Vault servers. If an application needs to get a configuration change at 2 in the morning, we need to have that path available. During maintenance windows, we still need a path available from the instances to our Vault or console servers. And then we also need to implement a consistent process for managing these configurations and secrets across all the teams. So everybody understands and knows this is how you accomplish this task. So along those lines, we wanted to sort of create a single point of management, one that actually had a historical view of configuration changes so we know who changed what and when they changed it. We needed the ability to roll back changes and perform some sort of code review of the configurations before implementation. And then lastly, for our production environment, we wanted to insert some approval process so that we get approval before we roll changes out to production. So our initial implementation started in about November of 2018. That month, we spent a week or two to implement the console and Vault architecture. Then we proceeded on the building the processes for configuration and secret management, and then spent time socializing those processes across the organization. That took a little while. And so since then, it's been onboarding the applications into our process and into our architecture. And of course, the team continues to go through the continuous improvement process of identifying the challenges, find the value, define the path, and then walk the path. So this is an overview of our console architecture. Again, pretty simple. We use the open source version of console, version 1.4.2. We have 2 data centers and a single console cluster that spans both those data centers. So we have console servers in both data center 1 and data center 2. And then we have a global entry point that's load balanced between the 2 data centers. Again, so any communication coming in can either go to data center 1 or data center 2 and then hit console servers in either data center. So if maintenance window, we're doing work in data center 1 or there's network issues, we obviously still have that single path from application instances to console. The same architecture applies with Vault. Again, we use the open source version 0.11.2. Again, 2 data centers. We have a single console cluster backend is for the database for Vault. We have Vault servers in data center 1 and Vault servers in data center 2 in the active standby. And again, a single point of entry globally that's load balanced between both data centers so that we always have that single point of access to Vault so applications can get their secrets. Okay, so once we built out the architecture, we had to go ahead and define a consistent configuration structure and naming convention. And again, this is sort of the language that we communicate to all the teams. When you're going to create key values, your application's going to use these key values, right? What paths do I access these on? And so we came up with a standard that was consistent across all the teams. And so for us in console, the KV store endpoints are referenced by a key path. And so for configurations across applications, we decided to use a key path that starts with /default. So again, these keys are referenced by any application, right? So any keys along this path, any application has access to. For configurations for specific applications, the key path would start with /env, an environment name, and the application name. And again, this would specify a path for an application for them to get their key values. So for an example, for app1, its key path would start with /env/dev/app1. And that would be different in a different environment, for example, like QA, /env/QA app1. So not only do we segment this by application, but we do by environment as well. And then for host-specific configurations, in those instances where a specific host needs something a little bit different from the application itself, we start with a /host and then the host name and the key. And again, this is just a consistent naming convention that we wanted to put out there across all of our teams in the organization. So we were speaking, again, the same language. And for our key names are just the words separated by a dash. So again, the key name would be application-URL. So we actually went ahead and generated a similar situation for Vault. And in Vault, our secret engines actually just simply store application secrets. We don't use it for anything else today. And each application is tied to a Vault secret. So the way we kind of structured it was we have 4 secret engines, right? 1 for each environment. So we have a /apps/dev, /apps/QA, /staging, /prod, right? And then within those secret engines, then we have the secrets which are tied to each application. So for example, we have a secret for app1, secret for app2, and then their actual values will be in the keys, in the key values within each secret. And so the naming convention for key names are words separated by a dot. Again, this is different from the configuration value names, right? And for example, it's spring.datasource.properties.user. And so what this allows us to do is, and we'll see in a second here, when we have applications that are trying to get values from Vault or console, we can specify the actual key paths, right, that will locate their values that they need. So let's actually start talking about how applications get their configurations, right? So up at the top, this is the configuration loaded application startup. So the first thing that happens is that our application instance starts up, and it's actually going to get 3 values. And we have Java applications, so these are in the Java ops, right? And we'll talk a little bit more about these 3 values that the application needs. Basically, it's, how am I going to talk and get my values from console, and what's going to happen if I need to actually update my configurations. So once the application gets those values, it starts up, and it's going to contact the local console agent that's sitting on the application instance, and it's going to be able to pull its values. And again, we're going to use these key paths or key prefixes to then locate the specific configuration information for the application instance. Down below, we want, obviously, our application instances to get changes hot. So this is the process for the configuration reload, right, when the application's running. And the way we implemented it was to use watches and handlers. We'll talk a little bit more about that in a second. But basically, a watch detects if there's a change along a key path, right? So again, these key paths in our architecture become really important because it identifies what we're looking for, it identifies where our values are, so that the applications know, so that console knows, and so that our teams actually know. And so this watch, when it detects a change, a create, an update, a delete along a specific key path, it goes ahead and initiates a handler. And for us, this handler is simply a script. It's going to pass a signal to our application. Now, our application is going to listen on a specific port. The handler is going to send this signal to that port, and it's going to tell the application, reload your configuration data. And so here are the 3 properties that I talked about that the application needs to pull at startup. The first one is the server list, and this is just really the connection that it looks for the data. Because we actually talk to the local console agents that are hosted there on the application instance, we specify the local host on port 8500. Again, this could be the VIP for the console cluster. We also specify a key prefix. And again, this goes back to that idea of this standard path for the applications of how they're going to pull their values. And so again, for each application instance, we can list a set of paths, right, of where they're going to look to get their data. And so in this case, the key prefix is /env/dev/app1. So this obviously would be the instance of application 1 in development, and it's going to look on this path to pull its key values. And then the last piece is the listener port. Again, this is the port that the application is going to listen on when our handler sends a signal to it to reload its application or the configuration data. So just a quick dive into watches and handlers for those that aren't familiar. Again, watches are a way of specifying a view of data which is monitored. So in this case, and we'll see it in a second here, in this case, the watcher's looking on /app/env or /env/dev/app1, and when any change occurs after that path, if a key's created, a key's been changed, it's going to go ahead and it's going to initiate the handler, which then again sends a signal to a port that the application's listening on to tell it to reload its configuration. And so here's the config.json, which is a configuration file for the console agent locally on the application instance. And here we specify the watch. And again, in bold, we can see that the path name's been specified. So when any key value's been changed on this path, then the handler script gets executed. So we talked about how applications get their configurations. Now let's move over and take a look on how applications get their secrets. Sort of a similar process. Application starts up, it's going to get a few properties, right, to know how to contact Vault and get its information that it needs. Once it starts up, it actually contacts the Vault URL to try to load its secrets. And the way we kind of manage that is token and policy, and again, the key path, right? So again, we're giving it a path, and it's looking for specific secrets along that path. And we can lock that down with policies and tokens. So taking a look at the properties, the first one is the Vault URI. This is how the application instance is going to connect to the Vault cluster to get its data. The Vault path, this is simply, again, that path to the data or the secrets that the application needs. And then the Vault token, and this is how we secure that data. So this application has a specific token to a specific path, and no other applications can access this data. And here's a little deeper dive into it. Again, each application has an associated secret, as we saw before. So again, the secrets engines are apps dev, apps staging, apps QA, and then the secrets underneath are associated to an application. And then each application has an ACL policy, which then says, hey, you know, who has access to this, right? Who has access to this secret? And then there's a token associated with that. So when the application calls Vault, it uses that token, which is then validated by the policy to say, yes, you have access to the data along this path. So we saw how applications get their configurations and secrets, but we really need a consistent process, right? How do we update, how do we create, how do we delete these configurations and secrets, right? So for the new process, we wound up choosing a Git Lab for source control. You know, it does branching really well. It allows a semblance of code review through merge requests. It has an audit history, so we know who changed configurations, when they changed it. It does rollback, so we can roll back the changes. The big piece, though, in our organization and in many organizations is there wasn't a high learning curve, right? Because developers already use this for their source control for the code that they write. And then we chose Jenkins as the orchestrator to run the scripts that will call the console APIs to actually implement these changes. Integrates with GitLab, and again, the teams that would manage this are already familiar with Jenkins and the processes. So let's take a look at the actual process of what we socialize to the teams of how you're going to add and update and delete these configurations. So a developer is going to come in and log into GitLab, and we have a properties repository. And the developer is going ahead and is going to update a specific property file. And we'll talk about how we segment our property files. It's by environment, for now at least. The developer goes ahead and pushes the branch to origin. The developer then submits a merge request, which allows a peer review or a team review to come in and check and validate the configuration. The merge is committed. Webhook triggers a Jenkins job. and controls passed over to Jenkins. So we have a script that runs in Jenkins. Jenkins job calls a script. And what this script does, it's actually going to look and create a list of all the changes that have just occurred. So any additions, any modifications, any deletions, this script is going ahead and creating a list of actions that are going to be taken against the console database. Once it generates that list, a second script is actually going to call the console APIs, and it's going to perform those actions. So regardless of how many additions, modifications, or deletions we have, the second script is going ahead and use the console APIs to make those modifications. And then controls head it over to console, where the APIs actually do the work. The only difference in this process between environments is, again, in our production environment, we want some sort of approval gate right before these configurations are passed on. So an approval process goes through, people make the approvals, and then the merge happens, and it kicks off the stuff through the Jenkins job. And so here's an example of our property file that houses the key values for the application. Again, this is in a Git Lab repository. Each one of these property files are going to contain the key and value. Each environment has its own property file, and here's an example of the console config-dev.txt file. Again, as you can see in this file, we have keys and values for app1 in the dev environment. Now, again, it only shows one application, but in ours, it would be there's app2, app3, app4, so on and so on. And we'll talk a little bit about a new challenge that we have around that. So we talked about the process of managing configurations. We had to come up with a process for managing our secrets. And it's a little bit different, what we implemented. It starts with a requester sending encrypted emails with some information. So a requester is going to send an encrypted email with the secrets engine, the secret, and a key. And the key is going to be a username, client ID, right? And the great thing about this and the structure and naming convention that we implemented is here, remember our secrets engine is the environment name, right? And the secret itself is the application name. So the developer doesn't have to figure out these random names for secret engines and secrets. They simply go, oh, I want to update app1 in dev. So I know, there you go, secret engine is dev, the secret is app1, and then they can provide the key. They send a second encrypted email containing the value, which in this case could be a password or client secret. And these emails go to the Vault admin team. Vault admin team gathers the data, they log into Vault, and they update and make the changes. And again, we'll talk about a challenge that we have around this as well. So, as part of our continuous improvement journey, we constantly cycle through these steps that we've been going over. And as I promised, here's a snippet of some of the things, some of the new challenges that we face that we have to go through the process with. So one of the things that we see is issues with console agents in different VLANs communicating with each other for health status. Obviously, we have application instances and multiple VLANs. A lot of them are protected by firewalls, right? We have some application instances in the DMZ. And the problem becomes when the console agents are communicating with each other for health status, right? So again, we had a single cluster. We have all these instances with console agents. They're trying to talk to each other for health status, and they're being blocked by firewalls. So we could obviously open up the firewall ports, which we did initially. But one of the problems we saw with this is for our Vault cluster, right? So our Vault cluster, on the Vault servers, we have a console agent because the console database is the backend for Vault. So what we saw is when applications in the DMZ couldn't communicate with the console agents on the Vault server, they were reporting them as unhealthy. And so what we saw was Vault was going through a process of electing a new active server. Now, normally it's not a problem, except when the applications start up, right? They need to grab their secrets. So they go to the Vault cluster, they try to grab their secret. There's no active server at the moment. They can't start up, they can't get their secrets, applications fail. So obviously one of the resolutions is to implement some sort of network segmentation to separate agents talking to other agents. So create separate network segmentations in different VLANs so only those agents can talk to each other and not across. Another challenge that we see today, again, our password rotation is sort of a manual process, right? Even though we now house passwords in Vault, still the creation of those passwords, right, the sending of the email, the implementing of those passwords is of a manual process. And so we need to move to a more dynamic password generation for our applications and database, right? And along with that, a better process for secret administration. Again, sending encrypted emails is great, but when you're doing this a lot of times, it starts getting confusing. Wait, this email, this password goes to which other email? So it's a challenge that we have to overcome. The last thing also is with the property files. As we saw, we have our property files segmented by environment, right? So all the key values for dev are in a single file. All the key values for QA are in a single file. In the beginning, this was great because it was the one spot developers could look. They could say, oh yeah, here's all my values. But as these configurations proliferated and we brought more applications on board, now this file is just untenuous. It's very big. So one of the solutions is to go ahead and split this out, these property files, as a per application, right? So app 1 would have its own property file that would contain its own key values. And that way we'd use the same process, but now we have separate property files per application. Okay, so today I talked about 24-hour Fitness's transformation using Vault and Console. Now we accomplished this by the following steps. Again, we identified the challenges, we found the value, we defined the path, and we walked the path, right? So how did overcoming these challenges bring value to us, right? That's the key point, right? What value did we get from this? So let's take a look back at the opening story where a configuration change was missed on a single application instance. Because we implemented that single source of truth today, right, that scenario would never exist, right? We aren't going to individual instances and making changes. We make a configuration change in console through our process, and all the application instances get that immediately, right? So that scenario doesn't even exist, right? So now everybody's happy. They get to start vacation early and go home, right? Of course, solving these challenges also allow us at 24-Hour Fitness to dedicate more time to what's important, and that's working out, right? But, of course, we're a fitness company, right? We're supposed to work out. That is until the next challenge. So thank you very much. Again, my name is Jason Yo, and my contact information is here if you have any questions.